Hello friends, this video on equilibrium part 12 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. So we have learned about equilibrium constant. The question is, where can we apply this? We have learned about Kc, Kp, right? But where can we apply this? What is the application of this equilibrium constant? So the first and the foremost use of this equilibrium constant is to predict the extent of the reaction on the basis of the magnitude. So the magnitude of Kc and Kp will determine what is the extent of the reaction. It will also tell you the direction of reaction, whether it will go the forward direction or backward direction. And it will also help us in finding equilibrium concentration. So we have done a couple of examples on this where we have found equilibrium concentration given the value of Kp or Kc. But these things we have not done. So let's understand all these things one by one. The first one is to predict the extent of the reaction. So high value of K implies there's a high concentration of product when you compare to reactant. And if the value of Kc is greater than 10 to the power 3, we say that the product predominates over reactant. That is, most of the reaction is done. The reaction has moved on this side. If you see, Kc is equal to 10 to the power 3 here. So anything greater than 3 is this side. That means the product, we have more and more products, right? If the Kc value is less than 10 to the power minus 3, this value, that means the reactants predominates. That means the reaction hardly happened. Very few chemicals in the reactant combine to form product. Very few. And if the Kc is in the range of 10 to the power minus 3 to 10 to the power 3, that means we say that both reactant and products are there. We'll take some examples. For example, of Kc greater than 10 to the power 3, we have when you react H2 and O2, it gives 2H2O, right, at 500 Kelvin. 500 Kelvin. So for this reaction, my Kc is very large, and that's why if you see, most of the reaction goes in this forward direction and water is formed. Or you can have this hydrogen gas plus chlorine gas. So if you react to give 2HCl, both are in equilibrium actually, so I'll put the sign. But most of the hydrogen and chlorine gas react to form HCl, right? And here also, and this happens at 300 Kelvin. So for this reaction, my K is 2.4 into 10 to the power 47. For this reaction, my K is 4 into 10 to the power 31. If you see, they are very high values. That implies that in this case, most of the hydrogen and chlorine gas has combined to form HCl gas, right? That means my reaction is mostly in this side, the product side. Most of the reactants are consumed to form product. You can take one more example if you want. You take hydrogen gas and you take bromine gas. It will be in equilibrium with 2HBr at again same 300 Kelvin. And here for this, the K is 5.4 into 10 to the power 18. Very high K. That means in this case also, the reaction favors this side. Most of the hydrogen and bromine gas has reacted to form HBr. Correct. Let's take the example of this guy. K is less than, this is Kc, is less than 10 to the power minus 3. One thing you can do is you can reverse the reaction. If you reverse the reaction, if you reverse this reaction, for example, in this case, if I say 2H2O, I want to break to form hydrogen and oxygen. So this reaction, if you see, at the same temperature, K will be what? Very less. K will be 1 by, K will be what? 1 by this thing, 2.4 into 10 to the power minus 10 to the power 47. So if you calculate this will be 4.1 into 10 to the power minus 48. Very less value. That means in this reaction, most of the very few water molecule will break to form hydrogen gas and oxygen gas, right? So if your K is very small, that means the reactants are ruling. If K is very big, that means the products are ruling. Correct. I'll take one more example here. So if you have nitrogen gas and you react with oxygen gas, it will be in equilibrium, it will form 2NO gas. So at again 300 Kelvin temperature, my K is 4.8 into 10 to the power minus 31. This implies that very few nitrogen and oxygen gas will combine to form NO. Very few, because the Kc is very small. Correct. Let's take some examples for the Kc where my Kc is in this range, 10 to the power minus 3 to 20 to the power 3, where both products and the reactants are there in a comparable amount. For example, I have hydrogen gas, I react with iodine gas, it gives me 2Hi. So here in this case, my Kc is nothing but 57 at 700 Kelvin. So in this case, if you see it's 57, this is in the range of 10 to the power minus 3 to 10 to the power 3. That means in this case, if you see, I have almost equal number of hydrogen gas, iodine gas and Hi gas. Everything will be there. Or you can see N2O4 also decompose to NO2. This is also one reaction. So at my almost 300 Kelvin, this Kc will be 4.6 into 10 to the power minus 3. Again, this also is not very high, not very less. So in this case also, my both the reactant and product will be in the comparable quantity. So the point I am trying to say is, just by looking at the value of Kc, I can tell that whether for this reaction, most of the reaction or how much reaction will happen. For example, if Kc is very high, that means you can say that 99% of the reaction will happen, and 99% of this hydrogen and oxygen molecule will form water. If Kc is very less, you can say that even 1 or 2% of the reaction will happen, right? That means if you say in this case N2 and O2 combines to form NO. So in this you can say only 1 or 2% of the N2 and O2 will combine to form NO. Or in this case also, if you reverse, you will see that only 1 or 2% of the water molecule will break into hydrogen and oxygen. If my Kc is in the appreciable range from minus 10 to the power minus 3 to 20 to the power 3, in that case I can say that almost 40 to 50% of my reactants will react to form product. Correct. So that is giving me the percentage of reaction. Correct. This is what I got, percentage of reaction from the value of Kc or Kp. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.